Hello and welcome back to the channel. Today we're starting a new topic, equilibrium under the action of concurrent forces, and this will be the first video in a playlist where we're going to be breaking down this topic step by step. Alright, without wasting much time, let's get right into the video. Okay, so the very first question we want to tackle is, what are concurrent forces? Concurrent forces are forces whose lines of action all pass through a common point. Alright, so let's say for example we have a ring, alright, and then we have ropes attached to this ring. So we have a rope attached here, we have a rope attached here, and we have a rope attached to this side. Okay, now if someone stands here, right, and pulls this rope, someone stands here and pulls this rope, someone stands here and pulls the third rope, right? Forces are being applied. Okay, now these forces, the lines of action of these forces meet at this point, right? They pass through this common point. Okay, so these forces are concurrent. Okay, so this is the idea behind concurrent forces. The lines of action of all the forces acting on a body. It can be a box, for instance, right? The lines of action, if you have a force in this direction, force in this direction, force in this direction, the lines of action pass through a common point. Okay, that is what concurrent forces are. Now, when an object is under the action of concurrent forces, how can we tell that that object is in equilibrium? An object is in equilibrium under the action of concurrent forces, provided that 1, it is not accelerating. 2, the summation of forces acting on the body is equal to 0. 3, the summation of the forces in the x direction. Let's say, for example, we have our forces here. This is our y-axis. This is our x-axis. Okay, or our y direction or our x direction. So let's say we have force F1 acting here, force F2 acting here, force F3 acting here, force F4 acting here. The summation of forces in the x direction, which is F1 and F2, must be equal to 0. The summation of forces in the y direction, which is F4, F3 and F4, must be equal to 0. And if it's a three-dimensional, right, let's say we have z axis, and let's call this F5, and here we have F6. The summation of the forces in the z direction, which is F5 and F6, must be equal to 0. And if these conditions hold true, then that object is in equilibrium. Alright, so having understood this, we're going to go into solving problems, solving questions. See you in the next video.